This lesson deals with supplemental problem 4.4. You can find this problem in the ECE302 ebook in the Chapter 4 Supplemental Problems on page 3. 6 MOSFETs are shown below with various node voltages measured at their terminals. And can you predict the state in which each MOSFET appears to be operating if the threshold voltage is 2? Here's my gate, source, and drain. And this is an N-channel MOSFET. Let's find the appropriate voltages. Check the state that we're in. We need to look at the gate to source and the gate to drain. The gate to source would be 3 volts minus 2 volts, or 1 volt. The threshold is equal to 2, so that's less than threshold. And the gate to drain is going to be 3 volts minus 10 volts, which is minus 7, and that's less than the threshold voltage of 2 volts. Both the gate to source and the gate to drain are less than threshold. That's our definition of cutoff. Take a look at the second transistor. It's also an N-channel. Here's my gate, source, and drain. Let's find the gate to source voltage. So it's going to be minus 3 minus a minus 7. That's down over here. And that's 4 volts, and that's greater than 2. And then the gate to drain is minus 3 minus a minus 4, and that's plus 1. And 1 is less than 2. That's less than or equal to threshold. So here we have the gate to source greater than threshold, the gate to drain less than threshold. That's our definition for saturation or current saturation. Our next transistor is a P-channel MOSFET. Here's the gate, here's the source, and here's the drain. We're going to solve for the source to gate voltage, and that's going to be 12 minus 4, which is 8. 8's greater than the threshold of 2. And we're going to solve now for the drain to gate. Here's my drain, here's my gate, so that's 2 minus 4, that's minus 2. Minus 2 is less than plus 2, which is the threshold voltage. So we have the source to gate greater than threshold, and the drain to gate less than threshold. That's our definition for current saturation, or just saturation. Next transistor is an N-channel MOSFET. Here's my gate, source, and drain. And my gate source voltage is 6 volts minus 2, which is 4. That's greater than or equal to the threshold voltage of 2. And the gate to drain is going to be 6 minus 3, or 3, and that's greater than the threshold voltage of 2. So here my gate to source and my gate to drain are both greater than threshold, and that's our definition of the ohmic region. Next one is a P-channel device, and so here's my gate, source, and drain. My source to gate voltage is minus 4 minus a minus 3, so that's a minus 1, and that's less than 2. And then we have our drain to gate. Here's our drain, which is minus 2, and our gate is 3, so it's going to be minus 2 minus a minus 3, which is plus 1. And that's less than our threshold voltage of 2. So our source to gate and our drain to gate are both less than threshold. That's our definition of cutoff. Our last transistor is also a P-channel MOSFET, and here's my gate, source, and drain. Source to gate voltage is 9 minus 6, which is 3. Now 3 is greater than the threshold of 2. And the drain to gate is going to be 2 minus 6, which is minus 4, and that's less than or equal to our threshold voltage of 2 volts. Source to gate greater than threshold, the drain to gate less than threshold. That's our definition of saturation or current saturation. So you can measure these kinds of voltages in a circuit that you're trying to repair, and you can figure out the state of the transistor and see whether that makes sense based on where it is in the schematic. This is supplemental problem 4.4.